So knowing what we know about the inverses, I went ahead and made you a little chart. So if I have the sine and I've restricted the domain from negative pi over 2 to pi over 2, and my range because is negative 1 to 1 because the lowest ratio or smallest ratio is negative 1 and the biggest ratio is 1, then with arc sine, I just flip-flop these two things. Okay, so my arc sine will have a domain of negative 1 to 1. My range will have a go from negative pi over 2 to pi over 2. And then you've got cosine, and then you've got tangent, and then so on, remembering that you've got the reciprocals of these, and so their domains and ranges will be similar, okay, especially their domains, not their ranges. All right, so looking at that, what we want to do is go through and just do some examples so that you're not caught off guard. So what I have is, this is what I had last time. If I have y equals the arc sine of x, what that also means is, so remember arc sine, I can rewrite this as y equals the inverse sine of x. What that means is that x equals the sine of y. X equals the sine of y. Okay, so, hang on. And then one of the things that you need to know, sorry, I'm kind of sort of making sure I cover everything, is that if I write something like this, the inverse cosine of the cosine of x will equal x under what conditions? So here's what you need to recognize, is that the inverse cosine and the cosine will undo each other. And so, but the context has to be appropriate. So we have to make sure we're in the correct domain and that type of thing. But as long as that holds true, as long as we're in the correct domain, then these two things will undo each other, which means this thing will pop out. So what this is actually asking is what's the domain that will make that okay to do? So how are you going to restrict your domain for cosine? So we're going to go from 0 to pi. Or your publisher is going to say from 0 to pi. Okay. So all that's asking is what domain has to be in effect for these two things to undo each other. What domain has to be in effect for those two things to undo each other? So let's try another one. What about if I have the inverse sine or the arc sine of the sine of x? When will that be x? When will these two things undo each other? Well, what is your domain? What is your restricted domain for sine? It's going to be from negative pi over 2 to positive pi over 2. That's when you're going to be allowed to do that. So those are the conditions that's going to work that way. So now let's go find some angles. If I have the arc sine of negative 1, remember that my domain is restricted. So what that's asking, why can I never find the papers I want? Found it. All right. So what I want, remember with arc sine, is that I need to sweep back into quadrant 4 using negative angles, and I can go forward into quadrant 1, which will be positive angles. So in other words, where does sine equal negative 1? Well, sine equals negative 1 at 3 pi over 2, but I cannot say 3 pi over 2. Why? Because to get there, I would have had to travel through quadrants 2 and 3. So I need to use a negative angle to get there. So I need to drop down by a pi over 2. So if I drop down by pi over 2, I will get the ratio of sine being negative 1. So what this says is, where does sine have a ratio of negative 1? That is what that says. So let's try another one. If we have, hang on, I've got the arc cosine, or arc cosine of negative 1. Sorry, I started to write arc. I got the arc cosine of negative 1, which, remember, this can be written as the inverse sine, and this can be rewritten as the inverse cosine. I choose to write a sine and a cosine just as an abbreviation. All right, so where does cosine have a ratio of negative 1? Remember, you've got a restricted domain. So where is cosine restricted to? Cosine is restricted to the top half of the unit circle. So sine, cosecant, and tangent are going to be restricted to the right side of the unit circle, which will be from negative pi over 2 to positive pi over 2. Cosine, secant, and cotangent are going to be restricted to quadrants 1 and 2, which is the top half of the unit circle, or from 0 to pi. You will never, ever, ever use quadrant 3 in any of your inverse functions, okay? Because it doesn't live there. So where does cosine have a ratio of -1? Cosine is a ratio of -1 at pi, which is in quadrant 2, or the quadrantal angle that makes up quadrant 2. All right, so let's do another one. We've got the arcsine of √2/2. The arcsine of √2/2. So where does sine have a ratio of positive √2/2? Sine is positive in quadrant 1. So I need to know where in quadrant 1, this is a positive ratio, where in quadrant 1 does sine have a ratio of √2/2? And your answer is going to be a pi/4. So notice that the sine of pi/4 is √2/2. But the inverse sine of √2/2 is pi/4. So you're flip-flopping your inputs and outputs. What about the arctangent of √3/3? All right, so let me tell you a little trick that I use to memorize tangent. Tangent is going to be 0 or undefined, 1 or -1, or a √3 or a √3/3. So you've got 1s and -1s, 0's undefined, √3 or √3/3. So tangent grows. So I'm going to start at 0, and I'm going to do √3/3, which is a part. Okay, so 0, a part of √3, which is √3/3. 1, a full √3, which is just √3, and then undefined. So again, I've got from 0, √3/3, 1, √3, and undefined. Okay, so that's the way that I'm going to remember how to do tangent. So as soon as I see the arctangent of √3/3, well, first of all, this tangent is positive. Arctangent is allowed to live on the right side of the unit circle, so from quadrant 4 going smoothly into quadrant 1. And where does tangent have a positive ratio of √3/3? At pi/6. Okay, so let's do another one. What if I have the arcsine of negative √3/2? So arcsine is allowed to live on the right side of the unit circle, sweeping down into quadrant 4 and up into quadrant 1. I've got a negative ratio, which means I'm in quadrant 4. So where does sine have a ratio of negative √3/2? That's going to be at -pi/3. So again, if I take this and swoop down a pi/3, because 5 pi/3 plus 1 pi/3, that's the missing part. So I swept down a pi/3, I'll end up with a y-coordinate of negative √3/2. Okay, let's do some more. So we have, looking at my notes, the cosine or the arc cosine of √10/9. And I want to use my calculator for this. So first of all, you need to be in radians. So I'm going to grab my calculator, turn it on. I'm going to make it a little bit dimmer. Okay, so what I have is, first of all, go to your mode. Make sure you're in radians, which I am not. Go down, I said. Okay, so I need to be in radians. Hit enter. Now I'm in radians. And then I need to X out of there. And to get to the arc cosine, that's going to be printed on the calculator. So to get to it, I need to hit second and the cosine button. And you'll notice that the arc cosine comes up. So I'm going to do √10. And I'm going to come out of the radical, divide it by 9. And close my argument. Okay, so the arc cosine of √10/9. My handwriting is atrocious. And then what I get is 1.21. Okay, so what angle measure, wrong pen, what angle measure cosine has a ratio of √10/9, you can't see, at approximately 1.21 radians? So if you'll remember from day 1, we swept out the radians, and if this is a length of 1, then a single radian would be somewhere up in here. We're just doing a little bit more. Okay, a little bit more than 1 radian. So I've got the arc cosine of root 10 over 9. So now what I want to do is look at when I can and cannot apply the whole thing of trig functions and their inverses undo one another. So if I have the arc sine of the sine of 4 pi over 5, okay, the arc sine of the sine of 4 pi over 5. Well, theoretically, these two things undo each other, as long as my domain is correct. Where is 4 pi over 5? Well, 5 pi over 5 is 180 degrees. So I'm in quadrant 2. Arc sine is not allowed to live in quadrant 2. So I need to use some context clues and rewrite this thing, and then I can just pop it out. Okay? So first of all, what's your reference angle? So sine is going to be negative. And so looking at this, I'm at basically 4 pi over 5, okay? Which is going to be right in here. So my reference angle is going to be 1 pi over 5. But I need it to be negative, because sine is negative in quadrant 2. So if I'm going to play with arc sine is only allowed to live in quadrants 1 and 4. So my angle that I'm going to use is going to become the sine of negative pi over 5. Okay, so let's review how I got that. 4 pi over 5 is in quadrant 2. He's not allowed to associate with quadrant 2. So look at the positives and negatives. Sine is positive. Landagosian. Sine is positive in quadrant 2. So I need the associated angle measure in either quadrants 1 or 4 that will give me the same ratio as this does. Okay, so sine is positive at pi over 5. So basically what I just said was wrong. If I've got 4 pi's over 5, I'll land here, which is a pi over 5 up. So I need to go a pi over 5 up. And then I'll have the same ratio. So now that I am in an angle measure that arc sine can affiliate with, these undo each other, and your answer is positive pi over 5. Positive pi over 5. All right, so I butchered that one. Let's do it again. I've got the arc cosine of the cosine of negative 11 pi's over 6. Okay, the arc cosine of the cosine of negative 11 pi over 6. So first of all, am I allowed to be where this thing is? Well, arc cosine can only live between 0 and pi, quadrants 1 or 2. So I'm going to have to rewrite this as a coterminal angle in either quadrants 1 or 2. So if I look at my unit circle, I'm going to start here, and I'm going to rip back 11 pi's over 6, which means I'm actually going to be coterminal with pi over 6. So I can rewrite this thing as the arc cosine of the cosine of pi over 6. Now that arc cosine can affiliate with this and get the same angle measure, these two things undo each other, and my answer is pi over 6. Okay, so let's do a couple more. I want to use the cosine of the arc cosine of 1.3. I made big old parentheses there, didn't I? All right, so remember that the cosine of an angle equals a ratio, but the arc cosine of a ratio equals an angle. So this right here is a ratio. Well, what's the biggest that cosine can be? The biggest that cosine can be is 1. This is more than 1. So there's no way to make this thing work. Okay, this is not defined, because it gave you a ratio bigger than 1, and your cosine curve goes up to 1 and down to -1. So it's asking you what angle measure will give you a ratio that's bigger than 1. There's not one unless I start stretching and compressing, and I'm not going to do that because that's not what my instructions are. So now I want to find inverse functions. Okay, so this video is going to be just a little bit longer simply because, hang on, let's look. Can I get this done? Yes, no. We're going to do another video. Okay, here we go. We're going to do a third video for this one.